at its very atomic level. So if there is a user authentication, then it would be broken down into authentication services, which is separate to a user login services. And similarly, a product or a catalog will be broken down into different services or running into a different container that will be helping in independent development of these services. Now, let's see what are the challenges we are facing with the monolithic architecture. The first one is, it is difficult to scale. We cannot just add resources to the system and expect the system to be running at that particular level. So scalability is one of the issue. Any particular component in this monolithic architecture cannot be logically scaled to use more resources or to grow as a requirement arises. The deployment on these systems are very slow. Development requires the complete application stack to be redeployed. The chances of failures are very high in this kind of system. Also, if I need to put any new technology stack in the existing ecosystem, it is very difficult for me to design such a thing. For example, let's say, in case of any e-commerce platform, if I need to put some product recommendation AI-based algorithm, I cannot do that in a monolithic app. I need to redesign the whole application altogether. Now, let's understand what microservices are, because this is what we are going to talk on, moving from monolithic to microservices. So these are an architectural style where an application is built as a collection of small, loosely coupled services, each handling a specific business function. Each services, as we know, unlike monolithic, everything is tightly connected. In microservices, these things run independently of each other, and they talk to each of other components through the gRPC or API calls. It ensures that the data management is decentralized, and it allows us to define our programming language, whatever programming language we want to choose to work on any particular service. Moving on to why we need microservices. So microservices basically solve these 4 challenges which we face with monolithic. First is, it allows independent scaling of services. It allows faster deployment. We can quickly do development parallelly for multiple modules, multiple services, and can do deployments at the same time for all the systems and make changes in isolation. It provides fault isolation and resilience. For example, any one of the services, if it hits a bug, then the whole system won't go down. Only that particular service will stop working or may get, will not be working as effectively as it was earlier. This also enables team to use different technologies for different services. For example, some people can write application or a container-based application in a Go module. For like a catalog, e-commerce catalog could be written in a Go module, and a product recommendation algorithm could be done in a Python-based programming language. Now, with this, we will move on to how Kubernetes helps here in microservices. When I say microservices, basically, we are talking about containers here. Now, Kubernetes automates the deployment, scaling, and failure recovery for these microservices. It ensures if a service fails, it is automatically restarted without any downtime. It provides automated scaling, adjusts the resources dynamically based on the traffic. It provides a self-healing capability, like when a container fails, any container fails, it automatically restarts it. It allows for service discovery and load balancing. It ensures that the traffic distribution is managed properly. And it enables us for multi-cloud and hybrid cloud deployments, where the same application can be deployed onto any of the cloud providers which is available to us, or for usage, enabling us to move from one cloud to another without any major changes into the ecosystem. By adopting this Kubernetes-based model, we can now orchestrate our microservices much better and in a much organized way. However, there are some of the best practices to develop with Kubernetes. As we understand, the Kubernetes, the best practices to follow with Kubernetes is use infrastructure as a code, wherever possible. Like there is Terraform for infrastructure as code management. There is a Helm charts for versioning and standardizing the Kubernetes resources. Why we use this is to reduce manual errors, and in case we need to roll back, it is much quicker to roll back. Wherever possible, we should be following the horizontal pod scaling methods for better resource allocation. Tools like Argo CD, Flux can automate our GitOps pipeline and do a continuous integration code commit. Sorry, when we do a code commit, it can do a continuous deployment. Tools like Prometheus, Grafana, and Datadog for real-time monitoring, for metrics and logs. Sorry, next slide. Now, Kubernetes is okay, but how do we do development for Kubernetes? So there is a 12-factor method that has been built by Cloud Native team and CNCF Foundation. It is originally developed by Heroku. These are the 12 principles which allow applications to be portable, scalable, and easy to deploy in the Kubernetes environment. Some of the key ones are code bases, like there is a single code base for per microservice. That means create single repository for each of the containers, whichever you are working on. Dependencies, declare the dependency in your requirements file, NPM file, or in your Maven repository. Similarly, configuration, the configuration should be separated using Kubernetes config maps or secrets. I mean, for secrets, of course, Kubernetes secrets is not an ideal choice. You go for Conjure or HashiCorp Vault for that. Then there are backing services where the databases and message queues are not acted as a dependent service on that particular container, but rather a API-based model where events are then passed on to backing services. Concurrency is for horizontally scaling. Every container should expose its API via port binding, not via any runtime environment. The processes should be stateless unless and until there is a dependency where NFS or any particular storage has to be used. Then, of course, there is build, restore, run, disposability, and dev prod parity, where you have to keep your dev staging and production environment identical. The logs and monitoring and admin processing are something which has to be separated out of the overall application part, and then your application should follow these 12-factor method so that it can be highly likely to be deployable on a Kubernetes cluster. While Kubernetes is all good, but for small containers, a couple of containers, it is good to not deploy any service mesh. But when the communication starts to happen between a lot of microservices, then the service mesh becomes a requirement. Service mesh basically manages the communication between containers, multiple containers, multiple pods. In terms of Kubernetes, it is pods. Now, Istio, Linkerd are tools which can be used to manage the communication. They also provide traffic management, security, and observability. Traffic management in terms of when load balancing is needed, they provide the load balancing part. They help with A/B testing. A/B testing means like 2 versions of application you can test on the same Kubernetes cluster. They, of course, with the TLS encryption and everything, they provide end-to-end service encryption. Moving on to next slide. How do we secure our containerized application? Security is a top concern for everyone. Kubernetes is good to have, but it comes with its own challenges, like how the password would be maintained. What happens if a container is, when someone created a container, but it has a flaw in it, or it has a bug in it, or it is doing some data leak. For these, we have to follow certain principles, which is like role-based access control, first of all. So a single user should not have access to everything. A role should be defined for that particular user so that a user can access or should access only his or her cluster or his or her namespace. The container image scanning should be done whenever images are bought in from any external sources. Tools like Privy and Aqua Security do such vulnerability for container scanning. Secrets management, like Kubernetes data, sensitive data, where user secrets are shared, they should be stored in either in HashiCorp Vault or Conjure. Runtime security should be done using, there are tools like Falco, and Datadog security monitoring is another tool which does all these things. And without these security measures, a Kubernetes environment is vulnerable to all the attacks, misconfigurations, and of course, data leak. Security in Kubernetes is highly crucial because saying microservices, going microservices, and doing things in a secure way are 2 different things. Now, coming back to, this is my last slide. I'll go to the conclusion part. Here, I'm wrapping things up, but we will recap the key takeaways. First thing is monolithic application slows down scalability, whereas microservices enables agility. Kubernetes simplifies microservice deployment and management. Service mesh enhances communication while also maintaining the security. And security should be our first priority. We should, in the transformation, microservices and Kubernetes isn't just about technology. It's about building a resilient, scalable, and secure architecture. Thank you for your time, and I would love to hear your thoughts and answer any questions.